So in this recording, we're going to talk about few basics of the production theory. We'll talk about what is a production function, what is an isoquant, and what is the marginal productivity of labor and capital, what is diminishing marginal productivity of labor and capital, what is MRTS, okay, and how is this MRTS equal to the ratio of the marginal productivity of labor and capital. So these are the issues which we're going to discuss in the first topic for production, right? So the what is production function? So let me write the definition first. The production function shows the maximum amount of the good that can be produced using alternative combinations of capital and labor. So you write it like this, that Q naught or Q is equal to FKL. So this is a function of capital and labor. And this is telling the maximum amount which you can produce. So, I mean, for example, 1 unit of labor and 1 unit of capital can produce, let's say, 100 units of output. So that's a max, let's say, it can produce. It can also produce 90, it can also produce 10, it can produce 0, whatever. But it can, the maximum what it can produce, that is what the production function is. Now, similar to the concept of production function is the concept of isoquant. It's a concept of isoquant. It says this. So you have labor here. So you have labor here, you have capital here. Now, if you want to produce a given amount of output, what is the alternative combinations of capital and labor you can have? So if you want to produce a given amount, so this Q naught is given. What are the different combinations of capital and labor would be there which can produce this level of Q naught? This is analogous to the indifference curve in a consumer theory. So in consumer theory, you saw what are the different combinations of X and Y which can give a same level of utility to the consumer. Here in production theory, you have the different combinations of capital and labor which can give the same amount of output. So maybe you can use, let's say, very less amount of labor and more amount of capital to produce a given level of output, or you can produce huge amount of labor and less amount of capital to have a given amount of output, the same amount of output. So all the combinations on this graph is giving you the same level of output. So what is an isoquant? Let us just define that. An isoquant shows those combinations of capital and labor that can produce a given level of output. That can produce a given level of output, this thing. So an isoquant is going to be shown by this. So you want to produce a given level of output. What are the different combinations of capital and labor? Right. So what are the different combinations of capital and labor? So this is the way you write your isoquant, and this is the way you write the production function. Hmm. So this is what an isoquant is. Okay. Now, then you have the concept of, let's say you have the production function like this. F of KL is equal to K to the power half, L to the power half. This is a production function which is given to you. Now, if I say that you want to produce it for the 4 units of output, so this becomes an isoquant. Hmm? So a given level of output, I want to produce 4 units of output. So what are the different combinations of capital and labor which can produce this level of output? That's one thing. Fair enough. So what is the marginal productivity? So marginal productivity of labor would be, I mean, you use one more unit of labor. How much is the increase in the output? That is the marginal productivity of labor. You use one more unit of capital. How much is the increase in the output? That is the marginal productivity of capital. So MPL is what is the change in output when there is a unit change in labor. This you write as FL. MPK, what is the change in output when there is a unit change in capital? This you write as FK. So this is also greater than 0. This is also greater than 0, right? This we assume it to be greater than 0. They are non-negative. I mean, they can be 0 sometimes. So no firm is going to find it profitable to choose that input level which is going to be reducing output. So if MPL is negative, MPL is negative means what? If you use one more unit of labor, now output is going to be decreasing. MPK negative. You use one more unit of capital, output is going to decrease. So you won't do that. So MPL and MPK, please write somewhere. MPL and MPK are assumed to be positive, or we can say non-negative. Non-negative. No firm would find it profitable to choose a costly input that reduced output. So we'll assume that MPL and MPK are positive. Otherwise, just say in case of consumer theory, you assume marginal utility is positive. Otherwise, why will you buy a commodity, right? So in case if the commodity is not giving you, if the additional utility which you're going to get from buying that commodity is not positive, then why on this earth you're going to buy that? You won't. Uh, then the other thing is that the marginal productivity itself is diminishing. So if you keep on using labor on the fixed amount of land with a fixed amount of capital, then the increase which it it is going to make to the output, that increase is going to fall, right? So it's same as diminishing marginal utility. So Diminishing. Marginal productivity. Diminishing marginal productivity. Uh, so means what? That is del MPL by del L. That is your second derivative of the production function with respect to this labor. That is assumed to be negative. Hmm. Del MPK by del K is del 2F. That is assumed to be negative. So you cannot just keep on adding labor indefinitely to a fixed amount of land. So there is a limit to what you can add labor. Uh, so if you keep on adding labor to the fixed amount of land, then the additional labor, is maybe then because the marginal productivity increase in marginal productivity is going to get negative, right? So there will be deterioration in productivity because of that. I hope you understood the difference between MPL and D of MPL by DL. So MPL is assumed to be positive, but the change in MPL with respect to labor. So if you keep on increasing labor, this MPL itself is going to be negative. That's there. So you cannot increase the let's say labor with the fixed amount of land indefinitely. No, it's not going to work like that. Acha, there is another thing. There's something which is also called cross marginal productivity. Is something which is called cross marginal productivity. So you have what? So when the MPL is going to change, that is not going to change just because of the changes in the input for which you are trying to find it. For example, MPL is not going to change just because of the changes in the labor. MPL can also change because of the changes in capital. Now think about it. Of course, with a fixed amount of capital, if you keep on increasing labor, MPL is going to fall. But on the fixed, but if you're going to give this labor more capital, then the productivity of labor is going to increase. Huh? So, we generally assume that your inputs are cooperative. So you give, for example, labor a computer uh, or some other technological device. So with an increase in capital, the productivity of labor itself is also increasing. Uh, so here we are seeing DMPL by DL. Now here we are saying, here in this case, DMPL by DK, cross marginal productivity. So changes in MPL are not only dependent on how labor is growing over time. Hmm. But also on how changes, but also on changes, not how changes, but also on changes in other inputs as well. Right, beta? So how do you write this? Del MPL by del K. right? That is your FLK, and we generally assume it to be positive. So we generally assume that factors are cooperative. That factors are cooperative, right? Then there is a concept of something which is called average productivity. Mhm. Then there's a concept of something which is called average productivity. So APL is basically just Q upon L, your output per unit of labor input. Output per unit of labor input. Mhm. Okay. Other thing is when APL is at its max, APL is equal to MPL. When APL is at its max, then APL is equal to MPL. So you mean what by this? That APL is what? Q by L? How do you find out the derivative of, how do you find out the maximum of this? Del APL by del L? So it is L, denominator as it is, into the derivative of numerator with respect to L, that is del Q by del L, minus numerator as it is into the derivative of denominator with respect to L, that is 1, upon L square. So you've just used quotient rule and you want this to be 0 for its max. So basically you mean this. Hmm? But what is del Q by del L? MPL? So what is MPL? Is equal, I mean that is equal to APL. So MPL is equal to APL. MPL is equal to APL at its max. Now let us also talk about MRTS. Now you've drawn this curve, right? So MRTS is exactly like your marginal rate of substitution, right? So it is like your marginal rate of substitution. It is telling you the rate at which the labor can be substituted for capital, keeping the production constant, keeping the output constant, right? So if you move from point A to point B, here you are using L1K1, here you are using L2K2. So you move from point A to point B. So you are substituting capital for labor, right? That is, you're using now less capital and more labor. Now, when we talk about this is a huge change, but when we talk about MRS, I mean, this is an infinitesimally small change or just a per unit change, right? So that could be approximated with a slope of the curve like this. But this is the slope. Hmm? This is the slope here. So MRTS is what? MRTS is the slope of the isoquant. It is telling you the rate at which your labor can be substituted for capital. Let us just write this point. And so that, acha, one more thing. If you look at this one, this is steeper. This is flatter. So this is a huge slope. This is a less slope. So if you move from point A to point B, the slope is falling. Slope is falling. And slope is what? MRTS. Means MRTS is falling. as you move down along an isoquant, down right along an isoquant. So let me just write the definition. MRTS, right? The slope of an isoquant shows the rate at which labor can be substituted for capital. Keeping output constant. Keeping output constant. So what I mean, oh, what I mean is this. Mhm. So the MRTS is given by this, the slope of this line, right? This line. MRTS is given by slope of this line. So of course MRTS is going to be different at the different points. So the slope is, so it is a steeper slope. At point A. It's a flatter slope at point B. Hmm. Slope. Slope is, I mean, that's what your MRT is. So you can say that as you move from A to B, that is down right along an isoquant, this convex isoquant, what you find is that your MRTS is falling. But that is something which I'll do in the next class. But just think about it. So how you can write MRTS? So if you just want to find out the slope of this, that is just this. Minus of dk by dl, of course. Q equals to Q naught. I mean, Q naught is given for a given level of output. For a given level of output. So it's MRTS is negative of the slope of an isoquant. Negative of the slope of an isoquant. So one thing is that the value of the MRTS, of course, it not only depends upon the level of the output which you're going to produce, but it also depends upon the amount of the inputs which you're using. So here the value is going to be dependent upon the amount of labor input and the capital input which you're going to use. Not only on the output which you're going to produce, but the amount of the labor and the capital input also which you are using, right? That's one thing. And its value, of course, it depends upon the point at which you are going to measure. So of course its value is going to differ at different points along an isoquant. So it is higher at point A and it is lower at point B as the slope of an isoquant is declining, right? Acha, one more thing, just a very simple proof. You have, sorry, you have f of kl is equal to q naught. That's what an isoquant is. So if I'll just take the derivative, so it becomes what? Del f by del k dk plus del f by del l dl equals to dq naught. But this is just a simple your derivative rule. So how do you differentiate f of xy? Fx dx plus fy dy. I hope you know it from your partial derivatives class. That is, you do it this way. Fx dx plus fy dy. You use it like this. And fx is what? Del f by del x. Fy is what? Del f by del y. Like this. Hmm? You just use this. But what is del f by del k? mpk. Del f by del l? mpl. Along an isoquant, there is no change in the output level. So along an isoquant, dq naught is 0, right? So what you can write is mpk dk is equal to mpl dl. So dk by dl is nothing but mpl by mpk. So what it is what is this? So MRTS is the negative of the slope of an isoquant. So this is what? Negative of the slope of an isoquant, right? That is what MRTS is. And this is the ratio of marginal productivities. Of inputs. Ratio of marginal productivity of inputs, right? So what is it that we have learned in this? We understood what is production function, what is an isoquant, what are marginal productivities of labor and capital, what do you mean by diminishing marginal productivity, what is gross marginal productivity, average productivity. When APL is at its max, APL is equal to MPL. What is an MRTS? And how do you show that MRTS is equal to the negative of the slope of an isoquant and equal to the ratio of marginal productive inputs, right? Okay, so this is what I wanted to do in this class. Thank you, Beta.